So this is just a small demonstration. I've introduced the PC, R1, R2, R3, and PCG. And then I've also introduced networks, network between PCA and R1, that is network 10 to 0, meaning what 192.168.10 to 0. And then between R1 and R2, 192.168.20 to 0. And then R3 and R2, 192.168.30 to 0, and then R3 and PCZ 192.168.40.0. So those are the networks that I've introduced between these equipment. Simply, what we want to do is to demonstrate how routing normally takes place. So, routing services. First and foremost, devices within the same local area network will communicate without the assistance of a router. But when your traffic is leaving your local area network and going to a separate network, that traffic must go to the default gateway. And the default gateway for 90% of the devices is usually the router. They route on the local area network. In this scenario, the default gateway for PCA is R1, the default gateway for PCZ is R3. So those are the devices that we want to focus on. So each device, our switch has a MAC address table, a router has a routing table. So a router has a routing what? Routing table. Yes. So under the routing table, we want to talk about certain information. We want to talk about certain information. So here, I'll choose to put interface. After interface, I'll again say network. After network, and then I'll say hope. So I want to demonstrate to you guys how this the routing table normally works, how routing usually works. So under interface, under interface, and the interface I want to put maybe in this scenario, in this demonstration, I'll say F00 there. So PCA is connecting to R1 via F00, and then PCZ is connecting to the router via F01. Yes, those are the information you can put in place. So I'll say the router under the routing table will say under F we have F00, and then we have network 10.0, and then the hop count will say is what? The hop count will say is 0. So under the routing table by default, it will have the networks that are directly connected to the router. Always will have the networks that are directly connected to the what? To the router. So the first network the router has registered is F00, interface F00 of network 10.0, hop count is 0. Why are we saying 0? The trustworthiness of that network is extremely high. The lower the number under the hop, the higher the trustworthiness. So in a nutshell, it says, I prefer this route over any other route because it's directly connected. If I put one, then the trustworthiness of that network reduces a little bit, but it's way better than any other number except zero. Yes. So the other network it will add is 0, 0, 0, 0, 0, sorry, and then it will say, it say bit 00 of 20.0, and then the hop count it is write is 0. Why? Again, this is an interface on actually on the router, so it's favored because it's directly connected to the router, so the hop count becomes 0. So if somebody is talking to these destinations, the router by default will be able to forward traffic to these destinations. If PCA is talking to somebody on a 10 network, it's supposed to be directly, so it doesn't really need to do the routing process. But if somebody from 10 tries to talk to 20, the router will route. It will take you from one network to the other network. But that network must be registered under the routing table. For now, the default information that is on the routing table are the directly connected network. Let me write also the directly connected networks for the other router. So before I do that, let me copy this, Control A, copy, and then now I just paste here. I don't want to change a lot of information. So Okay. Uh, Two interfaces, big 00 and big 01. Big 00 has network 20. So big 00 and R2 has network 20. Hop count is 0 because it's
Okay.
directly connected. And then it also has gig 01. Gig 01 has network 30. Network 30, which is
Got you.
directly connected. So that's a good thing. So it will have a hop count of 0. And then I'll control A, copy. So R2 doesn't have any R2 doesn't have any other network except those two networks. It doesn't have any other directly connected networks except those two networks. So we shall move to R3. We shall move now to R3. I'll change that to R3. R3 also has several informations. The first information it has is the network 30.0, 30.0. That dot zero is directly connected under gate 001. So it will have a hop count of 0. And then it also has network 40.0 has 40.0. But remember 40.0 is F01. 40.0 is F01. So those are the networks under router 3. So those are the networks under router 3. So having that routing table, you have to ask yourself, from PCA, can PCA be able to ping R2? Can PCA be able? So PCA, if it tries to ping R2, this is what will take place. PCA will try to ping a destination that is under network 20.0. So the destination is not within its local area network. So by default, that traffic should be taken to router 1 because router 1 in this scenario is the default gateway for PCA. Once the data reaches R1, R1 will check, you're coming from network 10 and you're going to network 20. So network 20, do I know how to reach network 20? It will check, yes, I know how to reach network 20 via gigabit Ethernet 0/0/0. So the data will be taken to that interface. It will slide to R2. R2 will check who's the destination address. It will check, you're going to network 20, specifically me. So the router will want to acknowledge. Remember, IP is connectionless. So there is no way of having a mechanism to know the message actually reached the destination. The destination has to acknowledge. So in the process, R2 has to acknowledge to R1 it received the message, or R1 will keep on, or PCA will keep on sending data to R2. So to avoid this, or it will assume the destination is not there. So to avoid this, R2 has to acknowledge it received a ping from who? From PCA. Yes. So our echo reply should be sent from R2 to PCA. So in this scenario, R2 now becomes the source, and then this destination becomes PCA. So R2 is talking to somebody in network 10 because network 10 is the destination. PCA is under network 10. Does R2 know how to send data to network 10? It checks under its routing table and sees it doesn't know about network 10, so it won't be able to reply back to PCA, and that's how the ping will fail. Yes. Question.
Okay.
So once the data has failed, how then do PCA, how will PCA be able to ping now router 2? Unless you
This
introduce
wa-
a
this was
routing protocol,
this was my question.
unless you introduce a routing protocol, then these devices won't be able to communicate. The only time a PC will be able to communicate with a different network is if the network is on another local area network for R1. But if the data is going to be sent to a different router, then it means you must introduce a routing protocol. In routing protocol, we can introduce several options. These are the options that you can introduce. You can introduce an interior routing protocol or an exterior routing protocol depending on the topology. Under interior, we have static and we have dynamic. So you can statically teach the routers about other networks, or you can dynamically teach the routers about other networks. Under static, we're going to cover default and recursive. We can use the two, either of the two, to create floating. Under dynamic, based on your comfort, you can decide to use link state or distance vector. Link state protocols will allow each router to have the entire map of the topology. It's like you're flying from Nairobi to China, and then instead of you getting the stopovers that you're going to use to reach China, this airline gives you the entire map of the world, and then it's your work to choose which route to use to reach that destination. Each route on the way normally makes its own decision. When you go to distance vector, we are talking about distance and vector. This one, they give you the actual base routes to reach the destination, and then you're all going to use the same points to reach the same destinations. Yes, they have already pre-defined which route to use. So those are the, we are going to talk more about that information between link state and distance vector. Path vector BGP is usually used for internet connect, ISPs by the internet service providers, but you can as well play with them in future. Yes. Back to our class. The option one was static routing. Static routing will introduce network 10 to R2 manually. Tell R2 whenever you get a query for network 10, take that query to gig 000. But that won't be efficient because it will keep the network engineer typing destination and routes, telling the router what to do. So the router won't be able to work on its own. It will rely on information that comes from an administrator. And if a network is lost or a different route is created, the router won't automatically be able to adapt to the changes. So it's a little bit unable to flex. But with the dynamic, if I introduce any dynamic protocol, but should be the same for this level of learning under CCNA, you will be forced to introduce same routing protocols for the three routers, but in CCNP, we can mix the routing protocols under certain conditions. But right now, it's not advisable you mix the routing protocols. You need to learn some few things before you do that. So you use the same routing protocols between R1, R2, and R3. If we choose the same routing protocols, the routing protocols will automatically tell the router 1 to send its routing table to router 2, and router 2 to send its routing table to router 1. So if router 1 was to send its routing table to router 2, what will happen? Router 2 will open the information under the router, under router 1's routing table. It will check. You have network 10.0. You have 10.0 of hop count 0. So it will say under gig 000, I've learned about network 10.0, and then hop count is what? Hop count is 1. Why 1? Because it's not directly connected to me. I've learned about that network via a certain neighbor. Yes. So the trustworthiness of that destination is not that guaranteed as network that is under hop count 0. If you're under hop count 0, the destination is highly guaranteed, but with the hop count 1 is a little bit not guaranteed because it's not directly connected to us. It will again check. You have network 20.0, hop count is 0. We can't add network 20.0 because we already have the base route to that destination. So it won't add that network. Yes. Other routing protocols will create a backup, a secondary route to reach that one, but in this scenario, it won't. And then it closes there. So immediately R2 sends its updated, its own routing table to R1. The first thing it will do, R1, it won't receive data it had sent to R2. So R2 won't send information under gig 0010.0 with hop count 1. Anything you learn via a certain router, you can't send it back to the same router. We call it split horizon. You can't send data that I've sent it to you, back to me. So basically R2 will only send data containing gig 00 of 20.0 and gig 001 of 30.0. Those are the two networks R2 will send to R1. What will R1 do? You have network 20.0, I have 20.0. I won't touch on that because mine is the base route. You have 30.0. Again, it will say under gig 00 because that's the interface. We learned about that network. We have learned about 30.0 network. We've learned about 30.0 network. But it's not directly connected. It's not directly connected. So that's the network we have learned about. So what will happen? So that's now the updated database between R1 and R2. That's the updated database between R1 and R what? R2. We try now to do a ping. PCA trying to ping R2. The destination is 20 something. We didn't declare which exact IP address, but it's under network 20 something. That network is not within the local area network. So it is taken to the default gateway. In this scenario, the default gateway for PCA is R1. Once the data is taken to the default gateway, which is R1, R1 checks, you're going to network 20. Do I know about network 20? Yes. Network 20 is under gig 000 in a nutshell. So the data slides to R2. R2 checks, you're trying to ping me. I'm the intended destination. Okay, I need to send an echo reply. Remember, ping is an echo. So that guy sent an echo. Now I want to send an echo reply. So in the process of sending an echo reply, it becomes the source. R2 becomes the source from network 20. The destination is somebody under network 10. So it now decides to send the data. It checks on its routing table. Do I know about network 10? Yes, it checks. Yes, I know about how to reach network 10. It's on gig 00. No, I need to send the data to gig 00, but I know it's not directly connected to us. So it's a small possibility that it won't reach, a very tiny small possibility. But I'll send it to gig 0, 000. So it sends the data to 000, slides to R1. R1 checks. This data is coming from 20 and it's going to 10. Do we know about 10? Yes. 10 is directly connected to F00. So takes the data to F00. The data slides to the intended destination, which is PCA. And the ping is now officially successful. The ping is officially successful. So now we try to test. So remember, R1 and R2 did exchange information. If now R3 was part of the routing protocol, the same routing protocol, it will also exchange information with R2. R2 will send its routing table to R3. In the process, R3 will say, this is the routing table for R2. I can see you have network 20. On my database, I don't have network 20. So I'll say under gig 001, I've learned about network 20.0. Hop count is 1 because it's not directly connected to what? It's not directly connected to me. And then it will say again, you have 30.0, but I have 30.0 base connection, so I won't add that data. You have now 10.0, it will say again, under gig 001, I've learned about network 10.0, but this time the hop count is not 1, it's 2, because even that router learned about that network via a certain neighbor. So it's a friend of a friend. So basically, that network will have a hop count of what? So the trustworthiness of that data reaching that destination has reduced again. So immediately R3 sends its data to R2. Remember, anything it had learned via R2, it won't send. Split horizon. So it won't send data pertaining 20 and 10. It will only send pertaining 30 and 40. So R2 will say, okay, you have 30.0, I already have 30.0, best route to that destination. No need of me adding yours. Checks, you have 40. It will say now under gig 001. I've learned about network 40.0, and then the hop count is what? Hop count is 1. Trustworthiness of that destination has reduced a little bit because not directly connected to what? To us. So now we have introduced 40.0 with 1 hop count. Yes. And then immediately R2 sends its updated database to R1 so that R1 can have an updated database. R1 checks, you have 20.0, I already have 20.0. You have 30.0, so I already added that network. R2 didn't send 10.0 because 10.0 was learned by R1. So it will receive 40.0, the one that R2 had learned from R3. So that's why it has a 1 hop count. So it will receive that network. So it will say, gig 000 has again taught me about another network. 40.what? 40.0. Hop count is what? It's not directly connected to us. And it's again not directly connected to the neighbor that is giving us this information. So the hop count becomes 2.
Joseph, I'm lost. I got disconnected and I tried to come. I had to change even to my phone.
PCA tries to ping PCZ. Source is 10, destination is on a network 40. Because the destination is not within the local area network, traffic taken to the default gateway, in this scenario is R1. R1 checks, we're going to network 40, not directly connected to us, but we can, it's a friend of a friend because of the hop count. So our work is just to send it to gig 000, in a nutshell 000. So the data goes to 000, slides to R2. R2 opens the package and sees data coming from 10 going to 40. Do I know how to reach network 40? It checks, yes, under my routing table I've seen. To reach network 40, I need to forward the data to gig 001. But it's not directly connected to me. It's connected to a certain neighbor or a friend. So I'll send the data to gig 001. So it slides to R3. R3 checks. You're coming from 10, you're going to 40. Do I know how to reach 40? Checks on its routing table, says, I know about 40. It's directly connected to me. But on my scenario, it's under F01. So sends the data to F01. Slides to PCZ. PCZ open the message, checks, source is 10, destination is network 40, exactly me. So it says, okay, I need to acknowledge I've received that ping message, or I send a ping reply, which is an echo reply to be specific. The process, it becomes the source. The source becomes the destination, which is PCA. So now the reply is coming from network 40, going to network 10. So because the destination is not within the local area network, the traffic is taken to R3. R3 checks its routing table. Do I know about network 10? It says, yes, I know about network 10, but it's a little bit far, not directly connected to me, but I need just to send it to gig 001. Data slides to R2. R2 checks its routing table. Okay, it's coming from 40, going to 10. Do I know about network 10? Yes. It's not directly connected to me because of the hop count of 1. It's connected to my friend, but my work is just to forward it to gig 0. So slides to R1. R1 checks, you're going to network 10, you're coming from 40. Network 10 is directly connected to my F00, and then the data goes to PCA. PCA now officially receives an echo reply.